In the previous video, I briefly introduced the slow motion effect, also called bullet time effect, but I felt like such effect deserved a proper video. So today we're going to discover the ins and outs of making a cool bullet time effect in Unity, and we'll also fix some small issues. First, I'm going to give a sort of a reminder of what we're doing regarding input. So we have a project-wide input action asset, which we can modify in the input system package in the project settings. In here, I have a slow-mo action, which is a button bound to the numpad 0 key. Then on our player controller, we have a player input class, which is a class provided by the input package, and its behavior is set to send messages. What this means is that it will try to call a method for each input action on all the components on this object. And here we have our own component player controller. And to catch these input events, all we have to do is define these methods. So in player controller, we have defined onMove, onLook, onRun, etc. And for our purposes today, we have defined the onSlowMo method. So we're going to go into the player controller script. So we are using the Unity engine .input system namespace, and down here we've defined a region called input callbacks. For the callbacks of the player input class, you have to have an input value as parameter, and by doing so, these methods will be called by the player input script. In the previous video, we managed the slow motion effect inside of the player controller script. However, now we're going to do it in a separate script, and this refactoring will give us the opportunity of doing more things like modify the pitch of the audio and enable a post-processing volume when we are in slow motion mode. So we're going to create a script called bullet time manager. So I hesitated between slow motion manager and bullet time manager, and I decided to use bullet time manager. So let's go to scripts and let's create a new folder here. Let's call it game managers. And in this folder, we're going to create our bullet time manager script. So let's double click on it. I find finite state machines to be a simple way to make these systems. Let's create an enum to represent the states of the bullet time manager. So we can either be in the normal time state. Let's rename it to normal time. We can be either in the normal time state, the bullet time state, or in a transition between the two. Let's create two variables. Bullet time scale, which is a serialized float that we can edit in the inspector. Then target time scale that we're going to use in the transition. Then let's define a state variable and a couple of methods to manage the states. So a method to change the state and a method to update the FSM. In the change state method, we're going to set our state variable to the new state. And then below, we're going to handle what happens when we enter that new state. So if we enter the normal time state, we're going to call a method setTimeScale, and we're going to give it 1. And when we enter the bullet time scale, we're going to call setTimeScale with bullet time scale as parameter. And here is the setTimeScale method. So it's going to set time.timescale to timescale, and then time.fixedDeltaTime to 0.2 multiplied by timescale. I already said in the last video that 0.2 was the default fixed delta time in the Unity editor, and by doing this, we're ensuring that the physics stay smooth when we are in the bullet time mode. Also, perhaps this bullet time scale, we can keep it in a range between 0 and 1 just to avoid errors. Now let's handle the transition. Let's define a serialized float, transition duration. We're going to set it to 1 second by default. And let's define a private float, transition timer, to keep track of how much time has passed during the transition. Now in the change state method, we're going to add an if statement. If state is equal to transition, then we're going to set the transition timer to 0. And in the update FSM, if state is transition, we're going to increment transition timer by delta time. Now, if transition timer has reached transition duration, then we're going to change state to the target state, and we're going to define it here. Okay, so we have a target state and a target timescale. Now when updating during the transition, we're going to gradually set timescale. So we're going to get a normalized time by dividing transition timer by transition duration. So we're going to compute the current timescale. If target state is normal time, then we'll get current timescale by using mathf between bullet timescale and 1, using normalized time as a t parameter. Otherwise, we're going to get the current timescale by lerping from 1 to bullet timescale. So the opposite. Then we're going to call our set timescale method with the current timescale as parameter. So by doing this, I realized that the target timescale is useless. So we're going to get rid of it. Since we have the target state, we don't need any more informations. Okay, so we are slowly changing the timescale during the transition. And now let's use these methods. So we're going to define an update method, and in it we're going to call update FSM, and we're going to give it time.unscale delta time. So we're going to be playing with the timescale a lot, and we don't want that to affect the delta time that we're going to pass to the update FSM method. So we need a delta time that's not affected by timescale. In other words, this is the delta time in real time. Okay, now that we did this, we need a method to order the bullet time manager to switch to a state. So let's create a public toggle bullet time method. In it, we're going to check if state is bullet time. In this case, we'll change to the normal time state. Otherwise, if we are in the normal time state, then we're going to call change state with the bullet time state as parameter. Now, in order to access this script from other scripts, we're going to make it a singleton. So let's create a public static instance with a get and a private set. And I'm going to scroll down and I'm going to add an awake method. And here we're going to set the instance to this object. Now back to the editor, I'm going to create a new empty. I'm going to call it game managers. I'm going to put it at the top of the hierarchy. Let's create an empty child. Let's call it bullet time manager and let's add our script on it. Let's keep the bullet time scale to 0.4 and the transition duration to 1. I'm also going to add my UI manager to the game managers. This is just a way to better organize the hierarchy. Okay, now let's open our player controller script. We're going to go to scripts, third person controller, then player controller. Here we have the on slow-mo callback that we created in the last video. So instead of doing this, we're going to call bullet time manager.instance.toggle bullet time, and I'm using a question mark to keep the bullet time manager optional. So if we don't have a bullet time manager in the scene, nothing will happen in this method. Okay, what I'm going to do is I'm going to click on my bullet time manager, then I'm going to go here and enable debug in the inspector. That way we can see our transition time and our other private variables. So if I press 0 on the numpad, then we're going to switch directly to the bullet time state. And if I press 0 again, then we're going to go back to the normal state. This is not exactly the behavior that we want. So let's go back to the code. I'm going back to my bullet time manager. Here, in fact, we should not be switching directly to these states. So this code will make the bullet time manager switch directly from normal to bullet time states. If that's the behavior that you want, then it's okay. But in my case, I want there to be a transition. So instead of doing this, so if we are in bullet time, I'm going to set the target state to E state normal time. Then I'm going to change the state to transition. And if we are in the normal time state, I'm going to set target state to bullet time, then change the state to transition. And now I'm going to set my transition duration to 3. And you're going to see that transition timer will move from 0 to 3. And the time scale will slowly change from 1 to 0.4. I'm going to press 0. And now my transition timer is increasing until we are in the 0.4 time scale. And I'm going to switch back. Yeah, so the transition is maybe too long. So 3 seconds is too long. I'm going to keep it to 1 second. So our code is working. Okay, now let's add some post-processing effects to enhance the bullet time state. So we already have a global volume here. I'm going to create another volume. So I'm going to right-click on the hierarchy, then volume, global volume, and I'm going to call it bullet time volume. I'm going to create another empty called volumes. And I'm going to organize my volumes in here. So I'm going to put my global volume and my bullet time volume in here. And I'm going to put it at the top. Okay, so we have our bullet time volume here. I'm going to click on new. So by pressing new, Unity has created a volume profile. So we're going to set its priority to 1. our global volume has a priority of 0, and we want our bullet time volume to override the values on our global volume. We're going to keep its weight to 1, and our script will take care of changing that weight. So I'm going to override the bloom. When we are in the bullet time state, we really want a somewhat strong bloom effect. Yeah, by the way, make sure you reset the state of the inspector to normal, not debug. Otherwise, you wouldn't be able to see the volume inspector. I'm going to see what I did for bloom. So we have the threshold at 1 and the intensity at 1. So in our bullet time volume, let's set the threshold to something lower. Okay, so I settled on an intensity of 6 and a threshold of 0.5. This is perhaps a bit much, but this is the overall direction where we want this effect to go. So we want the world to light up a little bit and feel like you are in an alternate state. Perhaps we can change the scatter to 0.5. So I'm going to bring down the intensity a little bit. Perhaps 3.5 is good. Yeah, you can also change the tint. So this reminds me of Red Dead Redemption. When you go into bullet time mode, you have a yellowish screen, but we can do it in other ways. We don't have to do it in the bloom. So this is just the tint of the bloom. Then I'm going to add a lens distortion. Yeah, if we set the intensity all the way to -1, we'll get an effect like this. And if we set it to all the way to 1, we'll get this. So we want it to be subtle. So just a small distortion like this. So we're going to keep it at -0.1. And I'm going to keep all the other parameters to their default values. Then I'm going to add a color adjustment effect. We're going to change the saturation a little bit. We're going to set it at -15. So we just want the colors to be a little bit more washed out, not too much. Then let's increase the contrast. I'm going to set it to 30. As for the hue shift, I'm going to set it to -5. Just a slight change in colors. As for the color filter, I'm going to change it to a slight blue. So just barely there, something like this. Yeah, even a little bit of blue is already too much. I just want it to be a little bit blue. Yeah, so it doesn't even look like a blue color in the inspector, but it gives us that little effect. So by changing the weight, we can see the changes that we made. Yeah, perhaps the bloom is too much. So looking at the character, and if you imagine that we have a lot of characters with the white colors, then they're going to be too bright. I'm going to change the intensity of the bloom. Yeah, maybe let's keep it at 1.6. We don't want anything crazy. Okay. Then let's add a vignette. I'm going to set its intensity to 0.4 and its smoothness to 0.5. This makes the vignette a little bit more oppressing without being too much. So it's just a little bit more intense than what we have normally. And of course, you can add any effect you want. For example, you can increase the chromatic aberration. You can add a depth of field. So I added a motion blur effect, but I'm not going to tweak this further. Feel free to add any other effect you want. Let's go back to our bullet time manager. So let's open this script. Let's add a reference to our bullet time volume here. And let's add a method for changing the volume weight. So let's define a set volume weight with float weight. And we're going to simply set bullet time volume.weight to our weight parameter. Let's go to the bottom of the script and add a start method. So we're going to set the volume weight to 0. In the set volume weight method, I'm going to make sure that the bullet time volume is not null. So if it's null, we're going to return. And you know what? In the start method, let's also set the time scale to 1. Let's go to update FSM. So here we are setting our time scale to current time scale. Now we're going to set the weight of our volume. You know what? I don't like this syntax. So let's define two properties. So let's define a start time scale, which is going to be equal to bullet time scale if the target state is normal time. Otherwise, it's going to be equal to 1. And end time scale, which is going to be equal to 1 if our target state is normal time, and will be equal to bullet time scale if our target state is the bullet time state. And let's do the same for volume weight. So let's define a start volume weight and an end volume weight. So start volume weight will be equal to 1 if the target state is normal time, and will be equal to 0 if target state is bullet time. Then end normal weight will be equal to 0 if our target state is the normal time state, and will be equal to 1 if our target state is the bullet time state. So these properties will allow us to have a simpler syntax here. So we're able to say current timescale equals mathf_lerp from start timescale to end timescale with normalized time as third parameter instead of doing this. So we're going to remove these if statements. So let's do the same for current volume weight. So the current volume weight will be the result of mathf_lerp from start volume weight to end volume weight with normalized time as t parameter. And here we're going to set the volume weight with our method with our current volume weight as parameter. Okay, so that makes the syntax more simple. Now that takes care of the transition. But just for the sake of sanity, when we enter the states, let's set the volume weight to the actual value that we want. So when we are in normal time, we're going to set the volume weight to 0. And when we are in bullet time, we're going to set the volume weight to 1. Okay, now back to the editor. We can go to the bullet time volume and reduce the weight to 0, just so we don't see the effects on the scene view. So let's click on our bullet time manager and I'm going to set my volume here. So I'm going to set the bullet time volume to this reference. So it works, except by mistake, I used 0.2 as default fixed delta time. And in fact, it should be 0.02. So if we enable the ragdoll, you can see that it's very laggy. That's because the fixed timescale of the physics engine is very big. So we're going to fix this. I'm not actually going to use the 0.2 value. Let's go back to the script. In set timescale, I'm not actually going to use a value here. I'm going to use a default fixed delta time and we're going to define it here. So let's say private float default fixed delta time, and I'm going to retrieve it in the awake method. So let's go down to the awake method, and here I'm going to say default fixed delta time equals time dot fixed delta time. This way we have the freedom of setting this value in the project settings, and our script will use that value as the default fixed delta time value. So in this set timescale, it will use the default fixed delta time value and multiply it by our timescale. Okay, now I'm going to enable bullet time and press 1 on the numpad, which will enable the ragdoll of our character. When we move the camera, we have a nice motion blur effect. I personally don't like motion blur, but in this case, it's appropriate to use it with the bullet time effect. One thing I noticed is that in bullet time mode, moving the mouse is much faster, and I'm guessing that's because in the player controller, we use a smoothing code to smoothly rotate the camera, and we're actually using the scale time to apply that smoothing. That's why the camera takes a little bit more time to settle in its end rotation. So let's go back to the code. Let's go to scripts, third person controller, then player controller. Let's go to the late update method. So here we are changing the camera target rotation with a quaternion lerp, and we're using look smoothing multiplied by time delta time for the t parameter. So I'm going to cut this and replace it by t. Then I'm going to define the t parameter here. So instead of time delta time, we're going to use time.nscale delta time. Otherwise, for the movement of the character, we want to keep using delta time because we don't want the player character to move at normal speeds while the other characters and the rest of the world is in bullet time. Okay, so that fixed the issue. So aiming is not affected by the time scale, which is very good. It doesn't feel good when the input is affected by timescale, and this doesn't change the gameplay in any way because your character is still affected by the timescale. It's only the input of the camera that we're changing. Okay, now let's work on the audio. So first what we're going to do is we're going to play a sound effect whenever we enter or leave the bullet time state. So I created 2 sound effects here. This is the bullet time sound effect. And this is the same sound effect, but in reverse. I created these sound effects in FL Studio, then I edited them in Audacity. So we're going to use the first one when entering the bullet time mode and the reverse sound effect when leaving the bullet time mode. Okay, let's go to our game managers. Bullet time manager, and let's edit the script. So here I'm going to add some headers to the inspector. We're going to need a reference to our audio source. Then we're going to need 2 audio clips for bullet time entry and bullet time exit. So we're going to have an audio source on our bullet time manager. Let's scroll down to the awake method. If audio source is undefined, we're going to get it from the object using get component. Now let's scroll up to our change state method. When we enter bullet time, we will play one shot our bullet time entry SFX. Then we need to play our exit SFX when we exit the bullet time state. So we're going to do it before we assign the state variable. So we're going to play one shot our bullet time exit SFX. So to make the syntax of this method more readable, we're going to create two methods, onState entry and onState exit. We're going to move this code to the onState entry method, and we're going to move this code to the onState exit method. And in the change state method, we're going to call onState exit on our state, then assign the new state to our state. Then we're going to call onState entry. So this makes the syntax a little bit more readable. So now when we exit the state, if the state is bullet time, we're going to play bullet time exit SFX. And when we enter it, we're going to play bullet time entry SFX. Back to the editor, we're going to add an audio source to our bullet time manager. And we're going to keep the spatial blend to 2D because we don't need these SFX to play from a given point in space. Then let's assign our bullet time entry and bullet time exit. Okay, now that all the references are defined, we're going to play the game. Okay, so let's enter bullet time mode. Yeah, perhaps we need to play the bullet time entry when we exit the normal state, not when we enter bullet time mode, because we'll be in a transition. So I'm going to move this line to the onState exit method. So when we exit normal time, we should be playing bullet time entry. You know what? Let's go to the volumes, bullet time volume, and let's increase this vignette. Let's also add a chromatic aberration. Okay, now we're going to enter bullet time mode. And now we're going to exit. Okay, so this works. Now we have a problem with the audio. So in bullet time mode, when I shoot, it sounds the same as in normal mode, and this should not happen. So the sounds in bullet time mode should have a lower pitch, and perhaps we can also add some other effects to it, but mainly it's going to be the pitch. So we're going to change this. Let's go to Window, Audio, and Audio Mixer. And in the Audio Mixer, let's add a new mixer. Let's call it Game Audio Mixer. And I'm going to go to the master group. And here we have a pitch variable. I'm going to right click on it, then click on Expose Pitch of Master to Script. Now what we're going to do is change this pitch in the script. But first we have to assign our sound effects to this master group. So right now we have two sound effects. We have the shooting and we have the impact sound. So let's go to prefabs, gun, and we're going to open our gun prefab. In our gun's audio source, let's click on this little circle in the output field. Then we're going to select the master group here from our game audio mixer. And now all sound effects that go through this audio source will have to go through the master group in the game audio mixer. And any effect on that group will be applied to these sound effects before they are played. But like I said, we're mainly going to change the pitch. So there is another way to do it. In the audio source, you have a pitch value here. So you can change the pitch on all these audio sources in the scene, but that could take a lot of work because you have to go through all the audio sources in the scene. And it could get tricky because, for example, on some particle systems that are created and destroyed, you have to keep updating their pitch. So it makes more sense to route all these audio sources to the same group in an audio mixer and then simply change the parameter of that group and perhaps add some effects, and that would change all the sound effects that play. So that's a better approach overall. I also have a sound effect on bullet impact effects. So to play the sound effect here, I simply added an audio source with the audio clip here. I don't remember if I covered this, but this is a sound effect that I got from one of Kenny's SFX packs. It is set to play on awake. So we're going to change the input here. We're going to select our master group. All right. Now, both of these audio sources will go through the master group. And then for the sound effects that play on the bullet time manager, the bullet time entry and exit, it's up to you if you want them to go through the audio mixer group. So if they do, their pitch will change. Perhaps you want that effect, or perhaps you want them to stay constant no matter the time scale. So we're going to test both and we're going to choose what sounds best. Let's go to our bullet time manager. Let's change the audio header to sound effects. Let's create a header audio pitch. And let's have a reference to our audio mixer, a string which represents the name of our pitch parameter, which in our case is master pitch. Then a bullet time pitch, which is a float between 0 and 1, and we're going to set it to 0.5 by default. Now, like we did for the set time scale and set volume weight methods, we're going to define a set audio pitch method, which is going to call set float on our audio mixer, and we'll set the pitch of our pitch parameter. So what we're going to do is whenever we call set volume weight, we're also going to call set audio pitch. So let's do it in the update FSM method. So we're going to take a shortcut here. So we know that the volume weight is between 0 and 1. So we're going to use this as a T parameter in a mathf lerp between bullet time pitch and 1. And we're going to call set audio pitch with this value. Then let's go to the onState entry method. When we enter the normal time, we're going to set the audio pitch to 1. Then when we enter the bullet time, we're going to set the audio pitch to our bullet time pitch. And just for good measure, in the start method, we're going to set the audio pitch to 1. Okay, back to the editor. Let's go to our bullet time manager and let's assign the audio mixer. So we're going to assign it to our game audio mixer. As for our pitch parameter, it is set to master pitch, which is okay. And the bullet time pitch will be 0.5, which is okay, I guess. Let's test it. So we have to make sure that the output of the audio sources are not overridden. For example, in the NPC object, somehow this value has been overridden. So we're going to right click on output and click on revert. Let's also check the XBot prefab. I'm going to go to gun. Yeah, this is set and I'm going to enter the gun prefab. Yeah, so the problem with nested prefabs is that sometimes some values are overridden one level up. So you have to be careful. So I forgot to rename this pitch variable. So let's go to the audio mixer in expose parameters. So you can see that the variable is called myExposeParam. So let's change it to master pitch. Okay, now it works. Now we are setting the pitch to 50%. Perhaps you can set it to like 40 or 30%. So what I'm going to do is change the pitch to 0.35. Then we're going to test our sound effects when they go through the audio mixer group. So let's set the audio mixer group here. Yeah, perhaps the value of 0.35 is too much. Let's keep it at 0.45. So the sound effects for the bullet time entry and exit are going through our audio mixer. And this is the result. And when we exit, so it's up to you if you want them to go through that audio mixer or not. I'm personally mixed because at the same time, I love the distortion on the sound effects. But also, I like the original sound effects as they are. I don't want them to change. Yeah, so it's up to you. It's a personal choice. So we're going to switch to the red faction and then enable the bullet time mode. Yeah, all we need now is a jumping mechanics like in Max Payne and we'll have created Max Payne in Unity. So after all, I'm not going to output this audio source to our audio mixer group. I want to keep the sound effects as they are. So I just want to make a little tweak to our gun profile. So let's go to data, gun profiles, then blaster. So for the max recoil angle, I'm going to set it to 0.5. And for the max recoil angle random, I'm going to set it to 1. Okay, now the recoil is much more subtle. If you like this video and the content on this channel, then you can head over to the Ko-fi page of the channel. For as little as $5 a month, you can keep this channel going strong and help me produce more content and deliver much more value to you guys. So form the phalanx, defend the line, and thank you so much for your support.